Okay, thank you everyone. Thank you for coming. So I'm Suqiang Song. I'm a director and chapter leader in Mastercard. So today, I'm so happy to share one topic. We talk about AI as a service and build a shared AI platform based on the deep learning technology. Okay, at the beginning, it's kind of a little bit introduction about my company, Mastercard. I believe all of you know who is Mastercard, right? So we are one of the biggest network in the world. We have 2.4 billion cardholders globally, and we have a lot of big data. And actually, we have more than 20 years artificial intelligence and machine learning experience from the industry. And Mastercard keep investing more and more in this domain. And we accredited the APT in 2015 and the Brethren in last year. Okay, first question. So what is the AI as a service? So before we talk about the terminology, so let me start a simple but very popular the AI application or service in FinTech industry. So we call it the personalization framework. Okay, so first step, you do a lot of data input and harmonization, and you got something variable, and you run your machine learning job and to build the user propensity model, and then you can do the prediction. And then you have to associate with the business rule, define the offer, or like a point engine and loyalty program. And you try to combine the rule and your machine learning model output and put them together to generate the recommendation engine. And after you figure out the recommendation and the output, maybe you want to go to execution and fulfillment, so that how we get feedback to the merchant, a bank, and also the real consumer. And then after they do analytic and result and feedback, the whole loop. Okay, it's a very typical use case for AI application. So if we break it down a little more, it's a secondary layer. There's so many things we have to do to consider, right? Not just machine learning. You have to start thinking from the start to the end, the whole pipeline. And we do some abstraction. It's very typical, the step and procedure for AI pipeline, right? Across the whole process. Okay, so many things to do. How we can use the AI as a service to support this kind of application. So there's 3 modes from our understanding for the AI as a service in the market. The first one, so like people focusing on to build the machine learning, the framework. So there's the typical use case. So the data scientist is the most clever people in the world, right? But sometimes they are very struggling to build some sandbox or environment. And most of the requests to the data engineering team, hey, just build our environment for me, just build a Hadoop cluster for me, right? And from the platform team perspective, they try to build some sandbox for the data science team and let them, give them playground and let them start working. So that's the first category for the AI as a service. The second one, there's another tier on top of the framework we call the fully management machine learning service. There's another nickname we call the data science workbench. It's very popular right now. So like people can use the template, the pre-built model, and the drag and drop developer tool to simplify how to use the machine learning framework. The application team also can share the template and reuse the model, but they have to assembly and infer them into pipeline and business context. And the third one, we call more advanced one. They add an automated service, automation service on top of the full management machine learning service. So they consider the whole AI pipeline, not only machine learning, but also from the start to the end, the whole pipeline. They try their best to automate the data analysis, pre-processing, and the hyperparameter tuning, model selection, and put the model into production as automation as possible. And we see like we are using gasoline, like this is regular, this is plus, and this is premium. Okay, so what's their bigger difference between the 3 modes? So let me build some static model for that. For the first one, we call regular model. If we say like the cost, right, and the timing is our major concern. So there are so many the procedure and step across the scene, right? You can see the first mode for the AI platform, AI service, did not help a lot because they just give you the sandbox. They did not help you to reduce the workload from the feature engineering, the modeling, and the evaluation, benchmarking, and you have to do a lot of things to do the model deployment and serving. So normally, it took 6 weeks to build a new model. That takes a long, long time. And also the cost is very high. The human being label and also the infrastructure. Okay, the second one, the plus mode, absolutely, with the good data science workbench, they can reduce a lot of time and the cost to promote, develop a new model, and the modeling time drop down. And also the feature engineering and the evaluation benchmark drop down a little bit. But unfortunately, the data science workbench only focuses on the data science work, but not the whole pipeline. You have to spend a lot of time, again, to promote your model, the output, to adapt to the business context and the other data pipeline together, right? But sometimes you can save a lot of time. You can create a new model with like the 2 week. Okay, the third one. There are a lot of things in the market. I think the Amazon, they build something, the SageMaker. This comes in my imagination, is very like automation, the AI service, because they focus on the whole pipeline. They try to reduce, like equalize to the different steps for the whole pipeline. And the very important thing, they help reduce a lot of time to model deployment and serving, because people start paying more attention to that piece, because it's more critical thing. No matter which kind of the good model you created, if you couldn't adopt them into the real production, connect to your business, it's nothing. Okay, even we think about that, we want to go to the premium mode, right? So that makes sense. But there's so many challenges. There's the two major categories. One, we think the learning automation, how we can automate learning. The second one is how we can make the serving automation. So like the learning automation, there's so many work to do the feature engineering. There's no automation. The people have come down and to do the pre-computation about the variable and the feature, and they do the feature selection manually and back and forth. A second thing is the model scalability limitation. But sometimes you want to run automation in parallel, but sometimes, like our company, we have terabyte data, right? 100 terabyte data when you run machine learning. It's kind of a trade-off. How can you make your model scalability? The third one, yes, the heavily rely on the human being work. For the serving automation, how we can make the machine learning pipeline embedded into the existing data pipeline, including the ETL and also do the model serving. And we talk about the model serving, how we connect to the machine learning output artifact to the different contexts, offline, streaming, and real time. And just the powerful, the machine learning power and AI strength. So, and a lot of people consider the machine learning is very special, like alien, right? So, and the data scientist like God, right? But, so if you consider that, maybe you made a mistake, because sometimes you want to do the automation, we talk about the DevOps or the automation deployment. You have to consider data science artifact with the same thing like you're running the Java code or you're building some data model. Okay, so let me start one by one. What deep learning can help? We want to use deep learning is not because deep learning is the most advanced and the buzzword, right? So talk about AI, why you talk about deep learning. We want to use deep learning because deep learning really help. The first thing, like in the regular base, we run a lot of ETL jobs. Before we touch any machine learning job, we run a lot of ETL jobs to calculate, we call long-term variable. It's like this kind of thing. We want to summarize aggregator by user and by different multiple dimensions, right? Merchant, category, geography. You have to pre-computing this kind of thing before the data scientist say, hey, I want that feature, but give me time series by week, by day, by year. But if you run this kind of aggregation job on petabyte data, right? You can see there's a lot of challenge. Sometimes they will took about more than 17% of your time and resource just to do this thing. Okay, with deep learning. So we're assuming the deep learning can really help to reduce a lot of work for the feature engineering. Because think about that, we're using some user item like the deep learning algorithm. So there's a lot of embedding layer we define. So they try to combine the user and atom combination. Actually, they can generate 1,000, 10,000, 100,000 feature if you want. At that moment, when they run the deep learning algorithm, they generate the feature automatically. You don't need to pre-compute, right? So that's when we do the POC, we just get rid of all the feature engineering piece. We just say, hey, this is my column, this is a category. I want to use to my feature. I tell the deep learning algorithm, hey, this is my feature column. So that's something you want to do. You don't want to say, hey, this is my last 6 months for that particular user, how much total spend and total visit. And after that, we can save a lot of time to do that. The second thing we call the challenge about the model scalability. And we are running around the user-item propensity model. The best way, I think, we have maybe 10 million user and 1 million merchant. And we want to do the recommendation between them. So the best model, maybe you guys think, is a collaborative filtering, right? So, but unfortunately, we did a lot of testing and also to do the benchmark. Sometimes the CF model is not good enough to beat even the regular classification algorithm, like a linear regression, logistic regression, or SVM, or random forest, right? Because there's something limitation over here. So, and we have to go back to the regular classification algorithm. We run linear regression kind of thing. But the drawback, we have to focus on like atom by atom. Sometimes we have to tune by merchant level. So that is not a good idea to scale your whole model. Okay, with deep learning, there's a lot of neural network algorithm we can think about to improve the collaborative filtering algorithm. So there's 2 examples. One, the NCF, the neural collaborative filtering, right? It's based on the neural network to build the CF algorithm. And there's another one is very popular. It came from Google and Wet and Deep, right? So both of them, they construct this model, but also leverage the power for the deep learning. Another challenge is heavily rely on the human machine learning expert. So let me do a short survey. How many data scientists in the room? Just raise your hand. Okay, congratulations, you are on the top of the mountain, right? So it's like the company should pay a lot of money to the data scientist team because they are most valuable. Because if we want to tune the bigger machine, right, you have knowledge, you have skill for, you have much better, you have a PhD degree to do that, right? So, but sometimes, in the other hand, so many times we recognize the really blocker for the AI platform and project is a human being, is our data scientist. We have a few data scientists, not so much. But sometimes there's so many projects coming and they're so busy. We couldn't force our data scientists working 24 hours per day, right? But sometimes we really need them to do the human being tuning. It's not automation at all. Okay, we're assuming with deep learning, so there are so many, deep features from the, like they call trick, right? So, but including the internalization, L2, and dropout regulation, so many things, and so many optimization algorithms. And a lot of the deep learning framework, they pay a lot of attention to build some kind of automation mechanism to like make your model selection, benchmark, and kind of thing automatically. So that's another reason we want to try. Okay, so then let me share our exploration and evaluation journey. So because we know we want to use the deep learning and how we start the thing. I think people talk about a lot of things about deep learning. It focuses on some popular use case, picture recognition, voice recognition, auto driving. But think about it, we are a credit card company, right? Most of our use cases, we are treating the data is like a transaction. It's very well-structured data, right? Most of the time, we are running the AI and machine learning is for behavior targeting, fraud detection, and recommendation, whatever. Nothing associated with this kind of the popular use case. And also, there's so many requirements if you are really living in a real enterprise, so like Mastercard, we have legacy, we have so many policy regulation. So for example, so people want co-located with your machine learning platform and your data. Think about that. We have petabyte data, right? So let's say I want to run machine learning. I want to copy the data from one cluster to another cluster. So that will be nightmare in Mastercard, right? You move just the data. The movement of the data is very tough, right? People don't like it. And the second thing, the data governance, okay, number one consideration, right? So, and people say, oh, you are a critical company. You can target me, right? By my demography, my age, my something. Sometimes it's wrong. So in Mastercard, based on the regulation and the agreement, so sometimes, a lot of the time, we couldn't targeting consumer by their demography, okay? So like, the only thing I know you is just ID, token ID. I have no idea about your personal profile, right? No PCI API information. The only thing I have is your shopping behavior. That is all. And also, there's the GDPR, right? We all know it starts from Europe, right? It's the most highest constraint policy and regulation to protect the data privacy. But that's the good thing, to protect our consumer. And also, you have to do the seamless integration with the product and internal and external, the rebuild of them, rather than rebuild of them. And the most important thing, and the infrastructure team want you to share the infrastructure. They don't want you to build a new, brand new GPU cluster just for deep learning, right? You have to move data, you have to build a new infrastructure. And sometimes you have to work with other workloads together, like ETL, whatever, right? So you only have 3 or 4 hours per day in your Hadoop cluster to run your machine learning job. I don't think I own the Hadoop cluster forever, right? That doesn't make any sense. Okay, at the beginning, absolutely we try from the superstar, TensorFlow, Cafe2, whatever, right? It's a superstar. But we realize it's very hard to promote them to the real production. The couple of things, and they claim the GPU is much better than CPU, okay? And then we have to install the GPU cluster. The second thing, like, we want to install the TensorFlow in our stage. You know, Mastercard stage is not easy, right? You have to, there's so many regulations. It's very hard. And sometimes, because we are creating a model, it's not the picture recognition. We are creating a model, is a recommendation model. Unfortunately, if you check the internet, there are not so few use cases talk about recommendation engine based on deep learning, right? And the company keeps that as a top secret. They don't want to share. Okay, then you have to go open the box, open the TensorFlow with a low-level API to create your own model and tune them, and diagnosing and debugging. It was not the very good experience. And also the bad thing is they couldn't leverage the existing Hadoop cluster, Spark cluster we have right now, right? Okay, then we seek help to Spark. So what Spark can offer? So there are 2 categories. One, they call integration with existing deep learning library. TensorFlow on Spark, Cafe on Spark, right? That looks like it's a good design. And there's another trick. They say, I want to re-implement the whole deep learning algorithm with the Scala and Python in Spark natively. You can say this is another TensorFlow native on Spark. There's a lot of project over there. After the long-term evaluation and assessment, so I can share something more. Like then the master company like us, so we want to evaluate the open source project. And we have a lot of consideration, right? So how about the community, the popularity, the healthy, right? And we are more concerned about which company behind the community, right? Because we want to build a long-term relationship with the open source community. Sometimes you just give you the source code you can build by yourself. But for machine learning stuff, you want some guidance, right? You don't want to start beginning, hey, I'm a superhero, I can handle that. They are the best guy who know how to leverage the software and library. And also you can see the Intel big deal is on the top. I mean, only in that category. If you compare with the TensorFlow, they're not in the same level. But you come to the Spark, it's the best one from the GitHub perspective. And people talk about, hey, the TensorFlow on Spark is also good, contribute from Yahoo. Absolutely, but just check up with our use case, our limitation is hard to use because they also need the GPU and also the standalone job from the TensorFlow. Okay, we start our POC to benchmark. So we want to know, again, we want the model scalability, but we want without any the metric job. the metric dropping. So then we want to benchmark with the Spark MiLab, the traditional machine learning for the recommendation, the ALS, and also with inter-big deal like NCF and wet and deep. Okay, so after we run the POC with the real transaction data, the same cluster, the same time, same capacity, and run the different job, one different job, we got some result back. Look like it's pretty good, right? We can run the scalability also to keep the metric going up. So that's we have more confidence. Like let we try the big deal as the candidate for the deep learning on Spark. Okay, the next part, I think this is the highlight for this session, because I think a lot of people and the company, they're doing the POC for deep learning, but there are very few use cases go to real production. Why? I want to share some experience from our side. You need to do more, not only deep learning. Deep learning can help you to make learning automation, but sometimes when you talk about the model serving automation, they need to do a lot of things. There's a lot of gap. The first gap, incremental tuning. If you just recap the cost and time, right? How we can reduce the cost and time at the same time? You don't want to run your deep learning model with the 4-7-year data again, right? That's not making any sense. The deep learning is a kind of very expensive workload. That depends on how much approach and iteration you want to run and tune the learning rate. Sometimes you got a better result because after you run more approach, but sometimes you have limitation. So this is our strategy. We run the historical model for bank just one time, okay? 7-year data together, couple of hours, maybe daily, possible, right? Depending on the set. But after that, we are not going to rerun the whole data set again. We set up incremental learning by daily, weekly, something. And from our experience, weekly may be better because you don't want to tune the model so high frequent. It's not streaming or real time, the model tuning. It's just like in the regular base, we do the incremental. But even you do the incremental machine learning, you have something to think about that because the data is coming, new user, new item. How can you make that update with your model, right? Sometimes you have new user coming, you have to get all the historical data from that user and put into the fine tuning, right? It's something you have to talk about. And after you generate the model, you want to do the benchmark. This is my new incremental model. This is my old model. Which model is best? And you run the A/B testing. You run the model benchmark and evaluations. And after that, you say, oh, maybe the incremental model is better than the history model. So let's launch that. The next gap, the model serving to multiple contexts. You can see that picture. So we run some kind of thing like a real-time or near real-time offer recommendation to our consumer, okay? And we run the deep learning with the inter-big deal on our Hadoop cluster, Spark cluster. After that, we generate the model. And how we can use that model? And we have the authentication flow is real-time. We have streaming like every 10 seconds. We're holding the data in a buffer. And we have offline, right? So then you have to think about more, how to promote your deep learning result and the model to the different contexts. Right? That's kind of a challenge because you have to open the different box and put the new thing into the old box and connect them port and make them work together. The next gap. I think most of you guys, when you start using TensorFlow, people said, I can use the TensorFlow to do the image recognition in 2 hours. I totally believe that because there's so many reference, right? And video and also GitHub project you can leverage. Absolutely, you can do that. But return back to the real business, return back to the real production data. You have to use the low-level API to build your own model. I don't think we can build in 2 hours. Sometimes it's much longer time, right? That's because the API level is very low. That's the reason a lot of open source community like Kira, they build a high-level API on top of TensorFlow to simplify. It's that the same thing like Inter-Big Deal. Inter-Big Deal is very powerful, but it's something like TensorFlow. Their API is very low level. So when we started using Big Deal, we got a big trouble, not about the learning piece, it's how we can put our data and build some data pipeline and use the Big Deal. And we have to think about, from the model perspective, how to connect them together. And then we create a lot of things we call high-level API, from data pipeline, from the learning pipeline, and also we build a different pattern, like when you run the model, depending on the sampling, or depending on you want to run sliding, or you want to run just a one-time job. There's so many combinations. And then we build this kind of high-level API to simplify our application user to use a big deal. Okay. The next gap we call how we can integrate the machine learning pipeline to the existing data pipeline in your enterprise. I believe a lot of companies, they are running existing ETL pipeline. They're using Informatica, they're using so many things, right? They build the data pipeline. But sometimes people consider data mining, machine learning, or data science pipeline is very special. It's isolated. It's not belong to the real pipeline. It's very hard to make the tool or the workbench integrate them together. And then we try to use something kind of data pipeline engine. We build our own processor and the template. We try to make them smoothly. Like the machine learning is just one processor. You can embed the machine learning processor into the existing ETL pipeline. You get data and you do machine learning, you're serving a model. It's very like the same user experience like other data pipeline. So that's one example. So we launched something and we're using the Apache NiFi. And we connect all the ETL process in real-time streaming and offline. And we can easily put the machine learning processor or capability into those kind of data pipeline because they're part of the NiFi, the whole pipeline. It's very easy. And we build a lot of a template because from the business perspective, application, they don't want to touch the low-level detail to big deal. They just want to give me some kind of a simple configuration. So like which FI we are talking about, so how many airports you want to run, how about your learning rate? It's very simple, couple of parameters. But if you can build a template for them, they can easily use. They don't need to touch the detail. Okay, the last gap. So again, treat the machine learning artifact with the same position with other artifacts in your software design and the development lifecycle. You're writing Java code is very important. You build a web application. You build a data service. Exactly the same thing for data science or machine learning, right? Because when you want to really enable the automation deployment, DevOps, they must be part of the whole process. You have to package and version control them, right, in the same way. So like our approach with the NiFi, we can say like we can build all the pipeline and we persist into the NiFi registry, but that's not enough. How about your model file? How about your prediction result? That kind of thing. And we enable the integration with the NiFi registry and the existing most popular one like a Gate, Starch, and also like a Jack-in. And they run in the automation CI/CD pipeline. Also, in the real production, we can enable Kubernetes and do all things, the deployment. And by the way, so the Inter big deal and run in Spark. And we can fully leverage the power for Spark, the platform, because it's cloud native. I can easily run Spark cluster on GCP or Azure or even the AWS or even our own cloud native environment. So there's no big concern for that. Okay, 2 minutes. And we have a lot of feedback. We built a very good relationship with the open source community, and we got a lot of support from the Intel. So that's a valuable thing. But even that, we spent more than 6 months working together. Why? Again, I talk about that. It's not only to build a model on the machine learning library. You have to think about more. So after that, we give some feedback, and also the Intel, the whole community got a very positive response. And they build a new, they build a standalone team, and they want to build a kind of a professional service and also like the predefined pipeline and the model on top of the big deal model. So they call analytic zoom. Okay, if you ask me what's the best start point to use the big deal, I should recommend you guys to go to the analytic zoom because there are a lot of reference use case. Like our use case is on recommendation and there's redefined model, and NCF and YDB you can find over there, and also have some feature engineering abstraction. Okay, I think I run all the time, so thank you, everyone.
Have a big round of applause for Suqiang. Very dense topic.